Hey everybody, my name is Evan Harris. I'm an account executive here at Snowflake in Atlanta. Snowflake's a proud sponsor of the Georgia Technology Summit. Some of you may know Snowflake, and for those of you who don't, it's a global data platform for all your data and all your essential workloads with boundless and seamless data collaboration. Snowflake, the data cloud, is a fully managed service that's simple to use but can power a near unlimited number of concurrent workloads. We've become our customer solution for data warehousing, data lakes, data engineering, data science, data application development, and for securely sharing and consuming shared data. If you're interested in learning more about the data cloud, I encourage you to visit our virtual booth or visit our website to register for our upcoming summit in June. I want to thank you all for joining us here today and would like to introduce the panel you're all here for, Rise of the Machines, moderated by Megan Heinze, president of Idemia. Megan will facilitate some interesting conversation around machine learning with leaders from UCB and TIBCO. Thank you and enjoy.
Welcome to the Rise of the Machines panel. My name is Megan Heinze and I will be the moderator today. I work for a company called Idemia that does AI-based biometrics that leverages tons of data. And it's been very interesting in the last year because we've had to recognize people with and without masks. And with me are two experts, Rafiq Ajani, who's head of digital business and transformation for UCB, which is a pharmaceutical company. Prior to UCB, he spent over 22 years at McKinsey leading AI and digital transformation. He is also a member of MIT's advisory board for the graduate program in analytics and mentors early stage technology companies. So he's one to watch. In addition, I have Stephen Hillion. He was the founder of Alpine Data, which was acquired by TIBCO, which is a great analytics company, to build a collaborative platform for data science. Before that, he has had tons of history of building out huge teams and also machine learning. Today, we were going to talk about what is artificial intelligence and what is machine learning. Basically, AI is machines programmed to think and act like humans. Machine learning is basically a subset of artificial intelligence. The machines can automatically learn and adapt to new data sets without human assistance. So basically, the more information the machine gets, the more they learn. And if you think about it, you see it all the time with Google Maps. It gets smarter and smarter every time you open it. Every time I go to the airport, it's a little bit different based on traffic patterns. Every time I open up Netflix, it takes into consideration what I've watched in the past. And the Tesla, of course, is thinking about everything all the time, but who can really control the outside environment? And the car needs to be aware of all the different changes. So one of the big questions people always ask, will the machine replace me? And the answer is obviously no. You still need humans to program machines. So the belief is by Gartner, there will be a net increase of 2 million jobs by 2025. McKinsey believes that 375 million people by 2030 will need to change their occupations based on digitalization. And this totally makes sense. You think about it, we used to all go to Blockbuster to go get our videos. Those people's jobs, they did something else now. Now we all watch Netflix. So things change as we go on. Now I'm going to ask some specific questions. One of the things that we're always thinking about is, why now? Why has AI and machine learning become so important? So I'm going to go to Rafiq first. So we're hearing a lot about the fourth industrial revolution. What do you think it means? And what's all the buzz about?
Thank you, Megan. It's a pleasure to be here. I appreciate the introduction, and thanks for getting us going. I think that's a great question, by the way, right? It's a question we could spend half an hour talking about. And my opinion on this is that while all indications are that this is indeed the fourth industrial revolution, it might be a bit premature to deem it as such already, right? If you go back to the prior three revolutions, right, whether it's the steam engine or the mass production or even personal computing, when we were in those phases, I doubt we would have already deemed it to be an industrial revolution in its own right? And so as I look at the advent of kind of digital technologies and maybe specifically artificial intelligence, while all indications are that this is probably the fourth revolution, we might pause for a bit before we deem it as such. When you look at each of these industrial revolutions, really, there are a number of characteristics that you observe, right? That each of these phases brought about in the way we live our lives, the way we work, etc. And if we look at a few of those and try to ask the question whether digital technologies, artificial intelligence do represent some of those characteristics, I think that might lead us down to the answer of whether this is indeed the fourth industrial revolution. So let's look at a few of those, for example, right? The first one is, disproportionate, true growth in productivity, if you will. Each of these eras, each of these industrial revolutions brought about a significant growth in productivity, right? And if you look at digital technologies, you look at AI, it's definitely bringing about a lot of productivity in the way we work, the way we kind of live our lives, right? The second is the ability to potentially, solve what you would deem to be intractable problems, right? Even prior. So if you think about things we had to do before the era of personal computing, incredibly hard things that we just couldn't do. We would rely on a patchwork of things, large mainframes, etc. But then we got to the era of personal computing, and some of these problems that were deemed to be hard to solve suddenly seem to be easy to solve. And I think artificial intelligence certainly brings some of those characteristics to life. So to me, really, when you take a step back and say, what have these revolutions done? They've really transformed the way we look at labor and capital to drive value, to deliver services, to produce goods. And if you look at what we're doing through digitization, digital technologies, and artificial intelligence, I think a lot of that is true. And so if you believe all that, you do land on the conclusion that this is indeed we're in the midst of the fourth industrial revolution. But often, as is always the case, it probably take us 10 or 15 years to truly get to a point where we might be all able to conclude, or confirm that this was indeed the fourth industrial revolution. So all indications are it is, but I'll probably wait a bit before I deem it as such.
Okay. So, Stephen, where are companies in their journey to realize value from artificial intelligence and machine learning?
And thanks, Megan, as well. This is going to be a great discussion. I think, I'd say they're early. Companies are early for the most part. And I agree with Rafiq that we need to be a little bit cautious in terms of declaring revolutions. I would even say that I suspect this will be viewed as sort of a sub-revolution within the sort of the IT revolution of the last few decades. It's just another case in some sense of machines being used to automate processes. But how are companies doing? I think, well, clearly, there's been a sea change, since 20 years ago. There are routine use cases that artificial intelligence and machine learning are applied to: spam detection, fraud detection, the sort of product recommendations we see at Netflix and other recommendations from LinkedIn. Those sort of very routine applications have become quite common and sort of commonplace in our lives, all the way through to much more advanced applications of artificial intelligence. Obvious examples being like on my phone, voice, face recognition on our phones. I think those advanced cases, though, are really limited to a few companies. Most mainstream companies, your Fortune 1000 companies, companies that most of us work for that are not in, say, Silicon Valley, are a little further behind, especially when it comes, and maybe we'll talk about this a little bit more later, is operational machine learning. So certainly I think that most companies now have some sort of form of advanced analytics going on. They have teams of data scientists who are working with their data to produce not just reports, but sort of inferential insights from those data. But actually operationalizing that so that it actually affects what appears on your website or affects your manufacturing processes, that's a little bit more difficult, and I think we're still early there. And some are still struggling with the basics. I mean, I remember when I started my career, we were talking about, the 360 customer view and bringing all these data set sources together in a common repository. Even that hasn't really happened yet. People still struggle with data silos, which is the first obstacle that data scientists face. And so, so it's still pretty early, but the leaders in the space have clearly created a holy grail for everybody to aim at.
Well, fabulous. And you're really touching on how we're really going to create value leveraging AI and machine learning. So what are kind of the key lessons that we're learning from leaders around the organization and around the world in AI and machine learning?
I think if I share an opinion, maybe, and Steve, you can jump in there as well. To me, a couple of lessons, right? One, I think organizations that are viewing this as a technology-based undertaking, I think are struggling clearly, right? I think there's a recognition that this goes well past the technology, right? And it needs to be elevated at the right levels inside an organization, often at the CIO level, the CEO level, et cetera, right? I think that the companies that are still operating in these pilot modes, in these early places, in the lower parts of the organization are certainly struggling. And one of the challenges has been for organization to how do we elevate this to the level that it does merit this kind of a transformational thinking, right? I think Stephen's point earlier on the data side, I think is a critical one as well, right? I mean, I think, garbage in, garbage out, the insights you can generate are a function of the quality of data you have, how well you're able to integrate data from various parts of the organization, right, to realize true kind of significant disproportionate value. And so to me, that I think the data challenges are non-trivial if you think about it, right? I think the talent piece is another big challenge in my mind, right? I think this requires organizations to both bring in new kinds of talent, right, whether it's data engineering, data science, right? It also requires organizations to elevate their current skills, right? To take their business people and help them to become, digital first individuals who are thinking about how to derive insights from data, how to evolve their decision making to become more data-driven decision making. So I think those to me are some of the big ones, right? Which is how do you elevate this to the right levels inside the organization? How do you think about data, and how do you have a strategy around your data, and how do you integrate data from that might often sit in silos in various parts of the organization? And then how do you think about the talent, right? Both the new talent that you need to acquire as an organization and then kind of set them up in the right way to be successful, but also then to upskill your current organization, right? And the people in your organization today. So those are some of the big challenges that I think organizations continue to struggle with in my mind.
Yeah, and I think in terms
I was going to ask you, Stephen, since he just outlined very clearly, it needs to come from the C level of the organization. You need to look at talent. You need to look at clean data, et cetera. What are kind of your views of the biggest obstacles and challenges? Are they the same, or are there many more than that?
No, I agree with those. I think one of the lessons, getting back to your previous question about what lessons we've learned, well, around that data challenge, is that is the main challenge. You can't do the work if you don't have access to the data. And one of the lessons we've learned from the leaders in this industry, whether it's Amazon, Netflix, is if you look at those organizations, they have easy access, relatively easy access to a centralized collaborative environment with the possibility for data discovery there on a very broad basis. So eBay had early initiatives around their data hub, where you had a single place that you go to, which gave you access to all the data the data scientists could want, made it easy to search. If you look at what Uber has done with their Michelangelo platform, it is again a centralized hub for finding data and for operationalizing machine learning workflows. So I think that's one of the first things to do, just make sure that your data scientists have access within the appropriate sort of ethical guidelines to data. Also, I'll return to this operational aspect. That's one of the key challenges now. I think most people understand the value of open source as well as some proprietary tools for doing data science. The technology is out there. There's too much of it, and it's difficult to find your way through it, but it is out there. And these newer data scientists who come through some of the recent MA programs, they understand the technology. What is problematic is then operationalizing that in a high impact way. I think one of the things that you see again and again in the organizations that are most successful here are that they have taken high impact use cases, kept them simple, and made them operational. So to take, Megan, you mentioned Netflix, just as an example there, right? So probably the most impactful application of machine learning in almost any company is the notion of making recommendations. Netflix has their movie recommendations. They even opened this up to a competition. If you look at what really happened there, they had lots of great ideas, but they actually kept those models very simple and just made sure that they were fed directly to the user at every possible point. And obviously it works great. We're all completely addicted to Netflix.
So Stephen, you talked a little bit about giving your data scientists access to data? What's preventing them from getting access to data today? What's the number one cause of that?
I think it's still this age-old problem that data resides in silos and that it's difficult to get that all sort of fed together. Of course, there are technologies for dealing with this, data virtualization capabilities that allow you to federate queries across many databases. And then, of course, the notion of the data lake, where you can have big data systems which make it relatively easy to consolidate all your data in a single warehouse in the cloud, for example. But then you also have sort of a lot of governance around that, and that's totally appropriate. Of course, you need to make sure that data is protected, but you can't go overboard there. I think, we've all had a bit of a reaction against artificial intelligence, machine learning. It's been hyped so much, and now people are a little afraid of it, and sometimes with good reason. But I think we'll come back to realizing the value of big data in our own personal lives as well as for businesses, and understand that if we put the appropriate guardrails around the use of data, and I think the Europeans have done a great job of this, and make sure that we enforce those rigorously, but then also realize that there's a ton of value in that, and making sure that the data scientists have complete access to that. Also, data is just crazy and chaotic and poorly documented and so on. So again, that's the reason why I think you see this pattern of centralized collaborative systems that make it easy to search and annotate for data. Those are difficult to build, but I think they're essential.
Fabulous. So you just touched about it. Man versus machine. Will the machine run humans? We've seen through all the media and movies since we were growing up, the machine takes over the world. But what do you think about it, Rafiq? How will this affect human beings, both in how we live and how we work with machines?
I think, look, I think to me, as you pointed out at the start, right, the answer is going to be somewhere in the middle. We're going to need the humans. I think those humans are going to need to be skilled differently, right, to realize value from the machines. But if you wanted a real preview of how our lives will look different in the era of AI and the era of digital technologies, I think the last 13, 14 months of the pandemic have clearly given us a real preview into that, right? I mean, I think if you had said to me a year ago that, the number of cars that are now being sold online, we would actually not only just be looking at car reviews or exploring cars online, but really actually completing a purchase of a car online, I would have probably not believed it, right? You look at telemedicine, what's gone on, you look at the way we are working, often in this kind of a, remote virtual mode now. So I think how our lives will look different as these technologies continue to change and evolve and become more sophisticated. I think we've started to see not just glimpses, but maybe even broad-based manifestations of that over the last 13, 14 months, right? I think if you think a little bit about, right, how will we live our lives? I think to me, a couple of things. One, I think our reliance on technology to drive a lot of our day-to-day kind of activities, our day-to-day interactions, I think we'll see that continue to grow and evolve, right? I mean, I can't remember the last time I've actually started to or taken a minute to kind of understand where I'm trying to go. I just jump into a car and I just know I'll put on my navigation and I know I'll get there, right? So I think as you think about those kinds of technologies, I think those will continue to grow and evolve, right? In terms of how we work, I think that to me is probably two different things. One is the notion of this kind of hybrid working model, right? I doubt we'll get into a place where we'll all be kind of back 9 to 5 in our offices and so on, right? So we'll see just the way we kind of work on a day-to-day basis, right? The way we interact with our colleagues, the way we are organized to work, etc. I think those will change. And we've, like I said, the pandemic probably accelerated that by multiple of 4 or 10 or whatever, name it, right? I think the other thing is just the skills that we will want to exercise, right, or the skills we'll want to build, right. And so I think you'll see a spurt in EQ based, both in terms of how people kind of learn and the kind of coursework they go through and kinds of skills they build and the way they exercise that in the context of their careers, right. EQ, elements of creativity, I think will continue to rise, right, as we know that those are things that are unlikely to to get displaced by machines, right? And the third thing to me there is really, I think all of us will need to learn to be more effective users of machine, right? I think, Gary Kasparov, who lost to Deep Blue back in '97, has this really nice way of putting it. He says a strong chess grandmaster with AI actually loses to a relatively mid-tier chess player who also has AI, right? And part of it is the reason that happens is that the strong grandmaster inevitably overrides the machine when he or she should probably not be doing that, right? And letting the machine set free. In other cases, it's appropriate, where you're making judgment calls, where the machine's overlooking a set of things. So I think finding the ability to navigate that, ability to determine what decisions still are likely anchored in kind of human expertise, human instinct, human judgment, and how to then let the machine do its thing, I think is going to be critical, right? And so to me, I think a big skill for us in the future is going to be to use those that combination, right? If you look at something like in the medical professionals, and you look at things like radiologists and so on, right? I think we know those are problems that the machine can already do, actually diagnose diseases with a higher level of precision, higher level of accuracy, right? And so for the human being to attempt to second guess the machine, probably not a smart thing to do. On the other hand, kind of understanding the patient, what their needs are, understanding the emotions, the feelings they're experiencing, and working through that as a part of their entire healing process, I think is where I suspect human beings are going to have something special to bring. And so I think to me, that's some of the elements of what I think are going to change as we look at AI certainly becoming a much bigger part and a bigger mainstay in our lives.
Don't always humans second guess the machines, like you said. And so, for example, an MRI, looking at someone has cancer, are they going to say, is it right or wrong? You see doctors all the time looking at the stats. So who's right? Is the machine always right, or the people right? Or is it a combination of both?
I suspect it's going to be, when you have such a massive decision, right, or a massive determination to make, which is, right, does this individual, have a cancer or a tumor, et cetera, right? I don't think we're still yet ready to defer that uniquely to the machine, right? But if you look at least in constraints environment, in test modes, we're seeing that the machine is accurate beyond what even the best kind of radiologists are able to determine or diagnose, right, with MRI scans and so on. So I think we're probably already there in terms of the machine's ability to actually make those diagnoses, but I doubt we will differ uniquely, right? I get reminded of, if you look at a transcontinental flight between the US and Europe, 99%, 98% of that actually can get automated. Machines can just do that, right? But I doubt we're going to get to a point where we're going to actually have the pilot just be off for 98% of the time of that flight, right? Because whenever you think about a high risk decision, yet as human beings, I think we probably want the human involved quite yet, right? The same thing with autonomous vehicles. We're seeing that over and over again, right? Are we almost there from a technology perspective? Pretty close, if not all the way there. But are we ready to yet kind of let it loose on us? I don't think so, right? And that's part of it, because it's a big decision with high risk, and so consequently we want the human involvement. Some of this is still the human behavior more than the readiness of the technology, and so it'll be a matter of where we get to a point where the human behavior is willing to differ completely to
I think it's a question, right, of it's maybe a misunderstanding about where machine learning is applied. Machine learning isn't applied in a very infrequent events that require a lot of judgment and skill. And nobody's going to ask a machine to replace my doctor's judgment when it comes to looking at my MRI scan, or at least not for a very long time. But when you look at clinical trials, where you have to analyze hundreds or even thousands of images and genomic sequences and so on, and where you don't necessarily care about whether it's 100% accurate all the time, you're looking at the aggregate results. The interpretation of images by machines in clinical trials for, say, drug discovery, or for relating genomic sequences to cancer screening images, that's when machine learning can be extremely powerful. And so you see, even in the last year, the pace of discovery, obviously for vaccines, but also in the last few years for again, drug discovery, for processing images in cancer trials, and when viewing the efficacy of drugs and looking at the outcome of that when you look at the images, Machines are so much better at doing that because they can do it in bulk very, very rapidly. So I think it's all a matter of scale. Machine learning is very, very good at being pretty accurate enough when you have lots and lots of things to do, not in surgery.
Okay, good. Yes, I think humans need to be here for a while, especially still to program everything, correct? And thankfully, we did get, it does help, of course, with the machine learning, as you said. We wouldn't get vaccines as quickly as we had in this past year. So that's all fabulous. So how about talent, though? Talent is often seen as a roadblock. We talked about it a little bit ago, but what do we need to do to help companies scale? What talent is required?
Yeah, I think let me comment on this a little bit and also relate it back to the previous thing, because new jobs are going to be created, right? It's like we talk about all these revolutions and will it kill jobs? And no, I mean, we see like hundreds of thousands of new data science jobs being created, but even more broadly, when we invented the car, maybe people worried about whether carriage drivers were going to be unemployed. You certainly don't see many of them, maybe around Columbus Airport.
Unless you're in Central Park.
But obviously, cars created whole new industries, whole new scales of logistics, and so on. And as these revolutions happen, unemployment generally remains pretty constant, right? People find new ways to be employed, and I hope find them in more fulfilling jobs. And you see this now, talking of cars, right, with the revolution in self-driving cars, well, sputtering maybe, but in self-driving cars, and of course also in things like Uber and Lyft, where you see new jobs being created there, and lots of questions about how well paid those jobs are, and the quality and health insurance and so on that need to be examined very carefully. But broadly speaking, I think these industries lead to new jobs and more fulfilling jobs. And as you say, Megan, we now need more data scientists, and how do you find those? I see a lot of really talented people coming out of the new master's programs that you see at universities around this country and other countries that have been springing up in quite some numbers over the last few years. And also more informally, boot camps, online courses, MOOCs, where people can learn data science skills very efficiently. And this means that people can transition their own jobs. So I see a lot of people moving into data science jobs who were engineers, who were business analysts, who were used to dealing with Excel and were sophisticated with data, and now can learn about statistical techniques and about machine learning and apply those to that same data to do more advanced stuff. So I think there's enormous opportunities here through these informal courses and through paid courses, and then through some formal education.
Do you have a favorite website though, for people? Sorry, Rafiq. I was going to ask Stephen if he has a favorite website for people to go to learn more about artificial intelligence and machine learning and programming.
Well, in some sense, my favorite website would be Google. In that you can just learn so much, and I think you want to avoid getting sucked into just sort of one point of view about a particular technology, say, or about a particular way of doing things. But of course, just using Google is not great either. You're going to sort of, if you Google artificial intelligence, you're going to think everything can be solved by a neural network when maybe a plain old regression will do. And so I think Coursera is a great place to start. They have many great courses on machine learning, starting with Andrew Ng's. So that's a good place to start.
Right. Yeah. Sorry, Rafiq, you were going to answer a question?
Yeah, I was going to just take the talent question down a slightly different path, if I may. I think Stephen's absolutely right. Look, I think in terms of the core technical talent that you need to fuel and drive value from AI and digital technologies, I think that is certainly being solved as we speak, right? If you asked this question 10 years ago, I think there was probably a struggle, right? At least in academic environments, the focus was still very much on traditional kind of data mining and BI type technologies. But I think academia has caught up, especially in the last 10 years, where you have people who come in with these true data science skill, data engineering skills, the skills you need to actually work with large data sets and actually drive that to insights and hopefully shape the kind of decision making and the value creation, right? But to me, the two challenges that I observed when it comes to talent is one that you still need people who can actually take those insights that a data science model might throw at you and actually move it to true decision making, right? Set it in the right context in the business environment and actually determine what the implications of those insights are and how they might unlock value creation. And so to me, that's still where the challenge is, right? Organizations are still struggling to create that connective tissue between their strategic priorities, where they need insights to drive that value creation that big data can uniquely kind of bring to bear. And so there is a little bit of that where there's a talent gap in my mind, right? So organizations are still struggling. I think there's a concept that Lisa McKinsey's talked about quite a bit called translator, right? These are people who sit between the business side of the house and the technology side of the house and are able to kind of marry those insights into true kind of decision making, make sure the right questions are being asked, and then the insights are being actioned in a way that they can unlock the value, right? So that to me is still where there's a significant talent gap, and organizations are spending a lot of time and effort to bridge that gap with upskilling programs and things like that, right? So to me, that's one gap that I still observe. The second, I think, is organizing that talent, right? So you might have this technical talent. Very often it's distinct and different, right, from what the organizations have had historically. These are not people who sit in IT. They're unlikely to be successful in IT because they need to have a kind of business first mindset, right? They're probably not set up to be sitting in business. They may or may not sit in business, but sometimes that's challenging because they're out of the ordinary. Some of them are sitting in functional areas like finance. And so I think organizing that talent to make sure that they're able to actually work together in new and different ways to actually drive that value creation in these sprint modes. I think that's where the challenge is. So to me, it's not so much that the talent doesn't exist; it does. How do you organize that talent, and then how do you connect it back into kind of into the flow of business decision making is where I think the challenge is today.
Fabulous. So we have one more question. We just have a few more minutes. What is one piece of advice, Stephen, you would give to CEOs and CIOs to help them prepare for artificial intelligence and to change in this new paradigm? What is required?
For sure. I would really build on what Rafiq was saying, which I think is just so true. Often data scientists tend to sort of view the world from the data out, right? So it's like I look at the data, I come up with something interesting, I sort of present that to the world and expect the world to change. Instead of the other way around, which is understanding what are our high priority business problems and what can the data support. And also your point, Rafiq, about how you organize teams, that would actually be my one piece of advice, which is to create a small, initially centralized data science team so that they can learn from each other, establish processes, be managed centrally and benefit and learn from each other, but have that matrixed into the business. I see this pattern repeated over and over again at the most successful companies, successful in using data science, is that they have a centralized team, but they're firmly embedded into the marketing department, into the finance department, into sales, or wherever it might be. And then related to that, and you may actually find that those people end up really being embedded into those organizations, and they're really working for them, and then may spawn new groups within those organizations that are sort of satellites of that centralized data science team. And I think the other thing is related to that is having a champion for data science in an organization. So many people are vaguely aware of what data science can do, but are not fully educated about that and need to be made aware of the great possibility of what that data science team can do. And time again, when I'm talking to organizations, they say that one of the challenges that the data science team faces is they don't really have a champion. They don't know which project, they don't know how to prioritize things. When they do run into obstacles about data and operationalization, they need somebody who can interface with the rest of the organization. So that champion, somebody within the organization who can, in these early days of AI, really educate the company about the possibilities and generate new business for that team, new use cases, is I think a key thing to do as well.
Fabulous. What do you think, Rafiq?
No, I think Steve said it well. I think a number of those teams resonate for me, right? I think to me that the biggest advice I would offer is to truly view this as a transformation, right? So if you look at what Steve said at the start, with where most organizations are, right? They're either in a place where they're still very early and they quite haven't started their journey, or they are at a place where what I'll call kind of pilot purgatory, right? Where they're constantly spinning up interesting pilots inside their organization, but are not realizing kind of large scale value, right? Because they're not able to scale it, they're not able to replicate it, they're not able to sustain it, right? And then there are a few that have actually, moved the needle and are actually realizing large scale value from this. And so to me, if you think about that and you think about what really has made those leaders, what has helped them kind of make this all work, it's really, to me, they've elevated this into what is truly a transformation, right? And transformation not in a buzzword sense, right? Let me talk to three manifestations of what I mean by to view this as a transformation, right? The first one is to elevate it, to my earlier point, at the C level, right? This is a CEO topic, a C-suite level discussion, right? It can't be delegated to kind of middle level management, right? This is not, if you're going to drive value from this, you need to be elevating the dialogue, right? The second part of that to me is this is a people, process, and technology change, right? It's not a technology change. It is a technology change, but that to me is third in the list. This is the changing the people, bringing in different kinds of people, upskilling your existing people, evolving your process, evolving your decision making, right? And that's core as well. That last mile between insights and action to realize the impact. So to me, that's the second part of the thing. And then the third is technology, right? And being willing to be disruptive in the way you think about and how you use technology, right? So to me, that's the second dimension, right? And then the final thing to me is at the heart of all of this, that for this to be truly viewed as a transformation, there is an element of culture change, right? And so organizations that start from a place of humility, that are willing to embrace this notion of intellectual curiosity, are really, really pushing themselves to become a learning organization. Those are the ones that I think are going to really be able to drive value from this, right? So transformation, start at the top, make sure you have the senior most levels involved, see it as a people, process, and technology change, and then embrace this with a sense of humility, curiosity, and evolve your organization to become a learning organization. To me, if you do some of those things right, I think you're going to start to realize value.
Fabulous. Thank you so much for being on the panel today, Stephen and Rafiq. You heard it from them. C-level is most important. We need the scientists need champions throughout the organization. We need people, process, and technology change, and of course, culture change in order for AI to work. So thank you, everybody, for attending our panel. Have a great day.